Let's explore the intricate world of social media systems design. We will focus on building scalable platforms, similar to Twitter and Facebook. These platforms handle a massive amount of data and users. Here are the core requirements for building a social media platform. Functionally, the system should allow for post creation and sharing, the ability for users to follow or unfollow other users, a timeline or newsfeed to display content, and the option for users to like and comment on posts. From a non-functional perspective, we require high availability, aiming for 99.9% uptime. This means the platform is accessible nearly all the time. Low latency, less than 200 milliseconds, to ensure a smooth user experience. Eventually consistent data. While immediate consistency is ideal, it is acceptable for data to be consistent across the system after a short delay. Highly scalable system, capable of handling growth in users and data without performance degradation. Let's estimate the scale of our social media system. We anticipate having 100 million daily active users. These users will generate 500 million posts per day. Users will read posts 50 billion times per day. This results in 6,000 write queries per second and 600,000 read queries per second. The system will require 1 terabyte of storage per day to accommodate all of this data. Now, let's discuss the high-level architecture of the system. The user interacts with the system through client applications, either mobile or web. These applications communicate with the API gateway. The API gateway acts as a load balancer, distributing traffic to microservices. Microservices contain the business logic of the application. Microservices interact with the data layer, which consists of databases and caches. Here is the database schema design. First, we have the user schema. The user table will contain user ID as the primary key with a big integer data type, username with a maximum length of 50 characters and has to be unique, email address with a maximum length of 100 characters and has to be unique, the time the user was created, the user's bio with text data type, and the follower count with integer data type that defaults to 0. Second, we have the post schema. The post table will contain post ID as the primary key with a big integer data type, user ID as the foreign key with a big integer data type, the content of the post as the text data type, the time the post was created, the number of likes the post has with integer data type that defaults to 0, and the number of comments the post has with integer data type that defaults to 0. We have 2 primary models for feed generation, the pull model and the push model. In the pull model, feeds are generated on demand, requiring less storage but resulting in higher latency. In the push model, feeds are pre-computed, resulting in lower latency but requiring more storage. A multi-layered caching strategy is crucial for performance. At the application layer, we can use Redis cache to store user feeds and hot data. We can use Memcached to store database query results. At the edge layer, we can use content delivery networks or CDNs to cache media files and static assets. We can also leverage browser cache for client-side caching. Breaking down the application into microservices improves scalability and maintainability. The services are user service for profile management and authentication, post service for content creation and management, feed service for timeline generation and ranking, notification service for real-time alerts and updates, media service for image and video processing, analytics service for metrics and insights tracking. To achieve scalability, we can employ horizontal and vertical scaling techniques. For horizontal scaling, we can use database sharding by user ID or geography. We can use load balancing to distribute traffic across servers. Also, we can use auto-scaling to dynamically allocate resources. For vertical scaling and performance optimization, we can use read replicas to separate read and write operations. We can use connection pooling to optimize database connections. We can use asynchronous processing with message queues for heavy tasks. Here are some key takeaways to remember. Designed for scale, planning for billions of users from day one with proper architecture. Cache everything. Multi-layer caching is essential for performance at scale. Microservices approach to break down monoliths for better scalability and maintainability. Use smart feed generation by choosing between push and pull models based on user behavior patterns. Building social media platforms requires careful consideration of trade-offs. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.